Welcome to this Resizing Excel VBA tutorial. In this video we're going to give you an introduction to working with shapes in VBA. We'll begin with a quick look at the shapes collection and provide a few different examples of things which constitute shapes in VBA terms. We'll show you several different ways to reference shapes in the collection, including how to loop over the entire collection to process all the shapes that belong to it. We'll spend a little time looking at how to control the size and position of shapes using 4 basic properties, before we move on and look at ways to add a variety of different types of shapes to a worksheet. So we'll look at basic auto shapes, pictures, and also some form control buttons, including how to attach or assign macros to those buttons as well. The final part of the video is going to look briefly at how you can add and arrange multiple shapes using simple loops and calculating the positions of the shapes that get added. So it's not a particularly complicated video, but let's get started. Let's begin with a quick look at what sorts of objects VBA considers to be shapes. All I've done here is started a brand new blank workbook, and I've saved it with the name shapes and a macro enabled file type, so it's got the XLSM extension. All I'm going to do from that point is head straight to the Insert tab in the ribbon and just draw a few basic objects which VBA thinks are shapes. So I guess the most obvious instance of that is the auto shapes, which you'll find in the Shapes button on the Insert tab of the ribbon. So there's all sorts of different types of shapes in there, and every single one of these is considered to be a shape in VBA terms. Let's just draw a couple of really basic simple ones. You can just click on a type of shape and then either click once on the worksheet or head back to the Insert tab in the ribbon again, and you could also select a shape type and then click and drag to draw one of a particular size. We're not going to bother with any formatting at this point, so I've got a couple of auto shapes there. Back on the Insert tab in the ribbon, there's a few other types of things you can insert here as well that will also be considered shapes in VBA terms. Pictures, for instance, or clip art in fact. Let's insert some pictures, or at least one picture. If I click on the Pictures button, I can then browse to a location. It's pointing to my desktop at this point, and I've got a lovely little picture of Resizing there, so I can just quickly double click on that picture to insert it, and then that's also a shape in VBA terms. Let's have another look. If I go back to the Insert tab in the ribbon, there's also things like Smart Art. So if I click on the Smart Art tool and choose one particular type of Smart Art, I don't really care which one at this point, click OK to insert one of those. And then what else can we do? Oh, I guess there are form control buttons as well. So if I head to the Developer tab in the ribbon, we'll have drawn these sorts of things in various videos in the past to create quick ways for our users to launch our subroutines. So if I go to the Insert button on the Developer tab, I can choose to insert a button. I'm not going to bother attaching a macro to it. I'm just going to click the Cancel button at that stage. And then one last type of thing. You may have seen this in a previous video when we've worked with charts. So any embedded chart objects which sit on a worksheet are also considered to be shapes. So really quickly, I'm just going to create a quick simple sequence of numbers. So I'm going to type in the numbers 1 and 2 in a couple of cells, drag them down a little bit so it auto fills a sequence, and then from there I can head to the Insert tab in the ribbon and choose the chart option. So I'm going to choose to create one of the basic column charts. So let's just insert a basic column chart like so, and that's also considered to be a shape. So having done all that, what I'd like to do next is have a look at how you can use VBA to reference these existing shapes on a worksheet. So from here, let's head straight into the VB editor. I'm going to do that from the Developer tab and click the Visual Basic button, and then I'll insert a new module by right-clicking in the Project Explorer, choose Insert, and then choose Module. I'm going to create a quick subroutine that's going to be called Referencing Shapes to begin with. And in there, the very first thing I'd like to be able to do is refer to the collection of shapes which belong to this particular worksheet. Now, this is one thing that we do need to consider every single time we reference a shape. Each individual worksheet, and chart sheet in fact, has its own individual collection of shapes. So although there is a collection in VBA called Shapes, I can't reference it directly until I've referred to the worksheet to which the collection belongs. So all of my shapes of course currently sit on worksheet 1, which is also the active sheet. I can reference that worksheet using a variety of different techniques, as you'll be aware of from many previous videos. So I could say, for instance, worksheets and then say sheet 1, and then refer to the shapes collection there. The annoying thing about that is that I don't get any IntelliSense to help me out with the shapes collection. I could also say worksheets 1, I've only got one worksheet in the collection at this point, and then say .shapes, and again I don't get any IntelliSense for that. A slightly more convenient way to do it is to refer to the sheet by its code name. So it's got a code name currently of sheet 1. So if I simply say sheet1.shapes, you'll find that the IntelliSense pops up and provides me with this shapes property, which refers to the collection of shapes on the sheet. Now, just referring to the collection itself doesn't particularly do anything useful. Let's do something quick and simple, like let's show how many shapes we've drawn on sheet 1, or how many shapes belong to sheet 1 already. What I'm going to do is pop up a simple little message box that shows me the count of shapes in that collection. So message box sheet1.shapes.count, and you'll see the IntelliSense provides you with a long list of methods and properties for the shapes collection, but as with pretty much every collection in VBA, there's a count property which tells you how many things there are. So fairly unsurprisingly, if I were to run this subroutine, I'll get a simple message box popping up showing me that there are 6 shapes currently on this sheet. 1, 2, 3, 4, 5, 6. Of course, it's also possible to refer to a single individual shape in the shapes collection, and you can do that in a couple of traditional ways that you're familiar with from other collections in VBA. We can refer to a shape by its name or by an index number. So for instance, if I clicked on this heart shape, if I selected that shape, you'll see that in the name box in the top left hand corner of the worksheet, it tells you the name of the object. So in this case it's heart 4. Every shape has got its own individual name, so if you click onto the different shapes, you'll see the names of them appear in that name box. All the shapes collection is indexed as well, so like most collections in VBA, or at least in Excel VBA, the collection is indexed from the number 1. So the first shape that I drew was, as well as having the name Smiley Face 3, also has an index number, which in this case will be 1. So to reference those shapes, let's just try to select a shape in a collection using a simple technique. Let's go back to the VB editor, and I'm just going to comment out the message box line and write another simple little line that's going to say sheet1.shapes. Beg your pardon, I'll spell that properly. And then in a set of parentheses, I can either enter the index number or the name of the shape. So if it were to be an index number, for instance 1, and then I could apply the select method to the shape that I've referenced, and fairly unsurprisingly, if I were to restore down that window and then simply execute that subroutine, you'll find that it selects shape 1. I can also refer to the shapes by name, and to do that I'd have to take away the number from the parentheses and then in some double quotes write the name of the shape. So in this case it was heart 4. So it's not technically case sensitive, but it's always good practice to match case in VBA. There are some elements of VBA which are case sensitive. So having changed the reference to the shape, if I run the subroutine again, it will select heart 4 instead. It's also possible to refer to multiple shapes at the same time. The shapes collection has a range property which allows you to pass in either multiple index numbers or multiple names. So let's say for instance I wanted to refer to the first 3 shapes that I'd added to the worksheet. Rather than referring to the shapes collection and then immediately passing in a name, I'm going to refer to the shapes collection and then refer to the range property of that. So inside the range property I can refer to either a list of names or I can refer to a list of numbers. To make that work properly, what I have to do is pass the sequence of either names or numbers in via an array. So I'm going to do this using numbers to begin with because it's slightly easier to type in. So within the range property I can then refer to the array function, and then in another set of parentheses I can pass in a list of numbers. I'm going to go for array 1, 2, 3, separated by commas, and then close the extra set of parentheses there. So having done that, if I were to run this subroutine at this point, it will select the first 3 shapes that I'd added onto the page. If I wanted to do exactly the same thing using the names of the shapes rather than their numbers, I'd simply need to know the names of the shapes. So I know that this first shape here is called Smiley Face 1, if I just click away from that and select it. Oh sorry, beg pardon, Smiley Face 3. Then the heart was heart 4, and the picture was picture 5. So if I know the names of all the 3 objects, I can select those using VBA as well. So that requires editing the numbers to the names. So as I say, Smiley Face 3, and then we've got also heart 4, and then picture 5. Probably a bit of an unnecessary demonstration, but just to prove a point, you can reference them by name as well as by number, and again if I run the subroutine I'll get all those 3 shapes selected. Now, as well as being able to reference shapes by name and by number, you can also refer to just the selected shapes on a worksheet. So to demonstrate that, let's just click back into the worksheet, and I'm going to select first of all just the smiley face shape, and then I'm going to hold down the control key and click on the heart shape as well. So let's say I wanted to do something to just the 2 selected shapes. Let me head back to the VB editor, and then I'm going to create a new quick subroutine called reference selected shapes. And what I'm going to do here is say selection. So rather than referring to the shapes collection on the worksheet, you can refer to the selection property. Now the selection property is kind of dynamic and flexible. If you had a range of cells selected, then the selection property would reference the selected cells. If I had a chart object selected, it would refer to the chart, and so on. So in this case, the selection refers to the shapes I have selected. To refer to multiple shapes in that selection, there's a property there called shape range. Now sadly you won't see any IntelliSense appear for this, which is what makes it slightly awkward. And going further now, I don't really know what properties and methods I have available for the shapes, but effectively I can apply any property or method that I could to a single shape at this point. So I'm going to just very quickly change the fill forecolor of the two selected shapes. I'm going to say fill.forecolor.rgb equals, and then I'm very simply going to make it equal to one of the Excel RGB color constants. So I press Ctrl and space on the keyboard at this point and look for the letters RGB in the list. I'll find a whole list of named colors. Let's go with something like my favorite named color in this entire list is called Papaya Whip. It's not a particularly nice color, I just like saying Papaya Whip. So there we go. Having done that, if I were to run that subroutine, we'll see that the forecolor of those two selected shapes changes. We'll talk a little more about formatting shapes later on in the video, and when we do that, it'll help immensely if we have access to the IntelliSense to prompt us with what properties are available. One fairly convenient way to do that is using a shape variable. So if I headed back to the VB editor and created a new quick subroutine, let's call this using shape variable. All we're going to do is declare a simple object variable which can hold a reference to a shape. So I'm going to call mine sh and say that its type is a shape. What I can then do is set a reference in that variable, so I can say set sh equals, and then I just simply need to refer to a single individual shape on a worksheet. So in that case I could say sheet1.shapes, open some parentheses and some quotes. I'm going to go for heart 4, which is the one that I used before of course, and then hit enter, and that will set a reference to that shape object. The great thing about that is that should I want to modify anything about that shape now, I can say simply sh dot, and the IntelliSense prompts me with all the available properties. So let's go for a different fill color this time. I'm going to say sh.fill.forecolor.rgb, and then make that equal to, I think something like RGB hot pink is more appropriate for a heart. So having done that, if I were to run the subroutine, you'll see that it affects just that single individual shape. Now referring to shapes one by one or even as a group like this using the range property is all well and good, but if you wanted to refer to perhaps hundreds of shapes on the same page, it's awkward to write a single line of code for each one. So as you should come to expect by now from VBA hopefully, if you've got a collection you can loop over it using a for each loop, and the shapes collection is no exception to that. So let's have a quick go at creating a subroutine that's going to loop over the shapes collection, and to begin with all we'll do is we'll list out their names into the immediate window so we can see what the names of our shapes are. So I'm going to create a subroutine called loop over shapes, and then in there we're going to start by declaring a variable which can hold a single shape object. So dim sh as shape, just as in the previous subroutine. I'm not going to set a reference to a specific shape this time. I'm going to use this variable as a control variable to hold a reference to each individual shape as I process my loop. So to do this I'm going to use a for each loop by saying for each sh in. Then I've got to refer to a worksheet and then the shapes collection of that sheet. So sheet1.shapes. I'll give myself a couple of blank lines, and in fact let me just give myself a few blank lines to bring this up to make it slightly easier to read. And then let's have the next sh line, so that will make sure that we move on to the next shape once we finish with the first one. And then all I'm going to do at that point is say debug.print sh.name. So at that point, if I wanted to be able to see the results of this subroutine, I'll need to display the immediate window. So to do that I can either go to the view menu and choose immediate window, alternatively I could just press Ctrl and G, and then if I were to just run that subroutine I'll see a list of all the shapes that belong to that sheet being listed out into that little panel at the bottom. Now just as with pretty much every collection in VBA, as well as using a for each loop to process the collection, you can also use a slightly more old-fashioned for next loop. So to demonstrate how that works I'm going to create another quick subroutine which I'm called loop over shapes 2, just because I haven't got an inventive name for it, loop over shapes 2, and in this case I'm going to declare a variable which holds a simple number, so I'm going to say dim I as integer. The idea behind this is I can then write a for next loop by saying for I equals, and then set a lower bound and an upper bound for the range of numbers that we will loop over. So if I begin with the number 1, I would then want to end the loop with the number which corresponds to the maximum number of shapes in the worksheet. So I could say here sheet1.shapes.count, just as we referenced earlier on. So as we know in this case that will be the number 6. If I then give myself a couple of blank lines and say next I, what I could then do is reference each shape in the loop by referring to its index number using my control variable I. So to put that into plain English I can say debug.print, and then I would want to refer to my sheet 1 object, so sheet1.shapes, and then refer to the index number of the object in there using my control variable I. So sheet1.shapes I, and then I could refer to, let's say, let's debug.print its name property again. So having done that, I'm just going to clear out the contents of the immediate window, and then I'm going to run that subroutine just to demonstrate that it returns essentially exactly the same set of results, just in a subtly different way. There are different situations when these two loops are appropriate to use. We'll hopefully encounter a couple of situations where one is more appropriate than the other later on in the video. Now, one of the most important set of properties to do with any shape are the properties which control its size and dimensions, and there are 4 of these. There's a property referred to as left, which controls the distance from the left-hand edge of the sheet to the left-hand edge of the shape, and there's a corresponding one called top, which refers to the distance between the top of the sheet and the top of the shape. And there's also a property called width, which, as you'd imagine, controls the width, and then one called height as well. Now, all these values are set in units of points, and if you wanted to find out, for instance, what the values are currently, we could easily reference those properties quite simply using one of the techniques we've just looked at. So what I'm going to do is look at the properties of the smiley face 3 shape and then look at how you could subsequently modify those. Let's have a brand new module to demonstrate this. I'm going to insert a new module into my project, and then I'm going to simply create a new subroutine called check shape dimensions. What I'll then do is create a variable which can reference the shape, so that's, as we did earlier on, declaring a variable dim sh as shape, and then from there I'm going to set sh equals sheet1.shapes, and I know that the smiley face was the first object that I drew on the worksheet, so I can simply reference it as shapes1. All I'm going to do then is say debug.print, and then let's have a very quick look. I can say sh.left, comma, sh.top, comma, sh.width. Beg pardon, that's meant to be a comma rather than a full stop, sh.width, and then another comma and sh.height. So having done that, I'm just going to quickly clear the contents of the immediate window just to make things a little easier to read, and then run that subroutine just to print out the current values for the left, the top, the width and the height of that single shape. Now, changing the dimensions and position of a shape is incredibly simple. All of these properties are read-write, so as well as being able to check their values, you can simply modify them as well. And in order to do that in this case, I could simply say sh.left, and I'll make that equal to, let's increase that. So currently it's set to 53.25 points from the left of the page. Let's increase that up to, let's say 100, for example, and then I can say sh.top, and I'll increase that slightly as well. Let's make that up to 50, and then let's change the width and the height as well. So let's stretch it out a little bit. Let's say sh.width, and we'll make that equal to 100 as well. And then sh.height, let's make that a little bit smaller. So let's say sh.height equals, let's go 460 or so. So, having done all that, let's step through this procedure this time rather than running the entire thing, just so we can see each property being modified individually. So I'm going to use the F8 key to step through, and of course it'll print out the current dimensions and position as well, but it's going to change the left property first, which should increase its distance from the left of the page, then the top property next, which increases its distance from the top, then the width should stretch it out. So you'll notice that the left-hand side is the anchor. It stretches it towards the right, of course, so the left property won't change. It'll change the width, and then of course move that towards the right. And then likewise for the height, you won't see the top of the shape move at all. It will reduce the height from the bottom. So some very, very simplistic things you can do. Just enter raw basic numbers to modify the size and position of the shape. Now, as well as being able to type in raw basic numbers to position the object on the page, you can also set its position relative to other objects. So that could be relative to the position of other shapes on the page. So for example, should I want the top of my smiley face shape to sit exactly in line with the top of, let's say, the picture shape, which is called picture 5, what I could do is say sh.top equals, and then let's reference quickly sheet1.shapes, and I know that the picture that I added in was the third object that I drew to the page, so I could say shapes3 and then say .top there as well. So having done that, if I were to run this subroutine, I'll just run the entire thing this time, you'll see that the top of the smiley face shape sits exactly in line with the top of the picture shape. Another really useful thing that you can do in Excel VBA is position a shape relative to cells on the worksheet. So for example, if I wanted the shape to sit in line with, or at least be positioned towards the top left hand corner of cell B2, then range objects have a top and a left and a width and a height property as well. So let's say I wanted to position my shape to the top left of cell B2, as I said, back into the VB editor. This time I'm going to set the left property to be equal to, and then I can say simply range B2.left, and then same sort of thing, I can refer to range B2.top. So let's just change this from sheet 1 shapes 3.top to range B2.top. If I wanted to change the width and the height to match the size of the cell, well, it's going to be quite a small squished in face, but we could do the same thing just to demonstrate a principle. Let's have a quick go at doing that too. So let's copy and paste the range B2. In fact, what we could do with this is make it equal to the width and height of a larger range of cells. So let's say range B2 to range, let's go for C5 or something like that. So C5, and then we can say dot width. And then we can do exactly the same sort of thing, exactly the same sort of thing for the height as well. So I'm just going to copy that and then change the height. So that's range B2 to C5 dot height. Okay, so having done that, if I were to just run the subroutine one more time, and there we go. So we should find that the shape now is sitting exactly in line with the top left edge of cell B2, and its width and height fit exactly with that range of cells B2 to C5. Okay, so we've seen a few things you can do to reference existing shapes on a worksheet, but what if you wanted to draw your own? That's what we'll move on to doing next. Before I do that, I'd like to do a little bit of tidying up in the worksheet, so I'd like to write a quick subroutine that deletes all the shapes on sheet 1. We may well use this a few times throughout the rest of the video, so it's like a little utility routine, a little helper method we'll come back to a few times. So I'm just going to hide the immediate window by closing that one down, and then a quick new subroutine which is going to delete sheet 1 shapes. So a quick simple way to do that will be to write a loop. So just as we did earlier on, we're going to write a for each loop. So I'm going to declare a variable, dim sh as shape, and then from there I can say for each, I can spell for properly, for each sh in sheet1.shapes. All I'd like to do then, if I close the loop by saying next sh, all I'm going to do is say sh.delete, so it's not particularly complicated at all. Now, having written that, if I were to simply run it, I'll end up with all the shapes on sheet 1 being deleted. If you wanted to expand on that so that it deletes all the shapes in the entire workbook, so across every single sheet, or at least every single worksheet, you could write another loop which loops over all the worksheets. I appreciate that I've only got one sheet in this workbook currently, but we may well end up with more later on. So let me just copy this subroutine and then paste it in. I'm going to say delete all shapes instead of just sheet 1 shapes, and then this time I'm going to have a second variable which I can use to loop over the worksheets collection. So I'm going to say dim ws as a worksheet, and then in there I can wrap up the existing for each loop in another for each loop. So I can say for each ws in worksheets. So of course that will refer to the active workbook, assuming that I don't specify otherwise, and then at the end of the loop I can say next ws to move on to the next worksheet. I'm just going to indent my sub for each loop, and then the important thing that I do here is rather than refer to sheet 1 shapes, I can refer to ws.shapes. So that will loop over every single worksheet and loop over every single individual shape in that worksheet and then delete that shape. So we've got a couple of nice utility methods now we can use whenever we need to tidy up after ourselves. What I'm going to do now is insert a brand new module and then look at how we can start writing code to add new shapes to a sheet. I'll begin this module with a new subroutine called add basic shape, and then in there I want to show you how you can reference the shapes collection and then add a simple auto shape like a smiley face or a heart or a rectangle, something along those lines, one of the basic auto shapes as we've been using so far. So to do that I need to refer to the worksheet I want to reference, which is sheet 1 as usual, and then in this case refer to the shapes collection. Then if I enter a full stop there, the first few methods that appear in the list all begin with the word add. So depending on exactly which type of shape you want to add to a worksheet, you can use a different method for each one. We're going to stick with the most generic one possible at this point, the one called add shape. Now if I type in a space after the add shape method, there's a great big long list of properties or parameters to fill in. They're all compulsory as well. You can see the first one is type, so exactly which type of shape you want to insert. Then the left, top, width and height, and we know what left, top, width and height mean. We've just been looking at those properties earlier on. So the type isn't particularly complicated. You've got a lovely little select list or an IntelliSense list providing me with all the different types of auto shapes I could add. Let's go for MSO. MSO stands for Microsoft Office, by the way, so they're Microsoft Office constants. So let's go for MSO shape. Let's go for heart, why not? So I'm going to go for a heart shape, and then the left will be, let's just go for 20, 20, and then a width of, let's go for 72, 72 for the width and height. And having done that, if I were to just simply run that subroutine, I'll end up with a new heart shape sitting 20 points from the left, 20 points from the top, with a width of 72 points and a height of 72 points. Now, immediately after you've added a shape to a sheet, it's very likely you'll want to do something like format it, so change its fill colour or its outline, or maybe add some text to it, something along those lines. And in order to do that, you'd have to find a reference to that shape. That's slightly awkward to do at this point with the way that I've just added my shape. I suppose you could rely on the fact that when you add an object to a collection, its index number in the collection will be the highest of that collection. So what we could do, I suppose, it's a bit of a rough and ready way to do it, but what we could do is declare a variable that holds a number and then set that number to be equal to the count of shapes on the worksheet after we've added it, and then use that number to reference the shape. That's all a little bit awkward. So here's a much better solution. I'm just going to delete that shape manually first of all. So I'm going to select it and hit the delete key on the keyboard, and then back in this subroutine, what I'm going to do at the top is declare a new variable, dim sh as shape. And then I can say at the start of this line where I add my new heart shape, I can say set sh equals sheet1.shapes.add shape. Now the reason that I know that I'm allowed to do this is because the add shape method returns a reference to the object that it creates. I've got to do one more little tweak in terms of the syntax here. If I try to click away from this line of code, the entire line gets highlighted in red. And that's simply because of the addition that we've made to the start of the line. If we're using the add shape method and we want to return a reference to the object that's being created, then we must wrap up its arguments in a set of parentheses, a set of round brackets. So immediately after add shape, I've got to open a set of parentheses. The little tooltip that pops up there shows you that it does return a reference as a shape, which is why we're allowed to use this technique in the first place. Excuse me while I just change the width of my screen a little bit, give myself a bit more space to show you the code. So then I can close the round brackets or the parentheses at the end of that line, and then from that point I've got a nice simple reference to the shape. So should I want to change something like, again, its fill colour, for instance, just something quick and simple and easy to show, .fill.foreColor.rgb equals RGB hot pink again. So having done that, we can run the entire subroutine and we'll end up with a shape added to the sheet and formatted as well. So adding a basic auto shape is pretty straightforward. It's really just a case of selecting which particular type of shape you want. Let's have a look at doing something a bit more complex then. Let's try to insert a picture into the sheet. So as we did earlier on manually, I'm going to insert my wise owl image into the worksheet. So I'm going to create a new subroutine called add new picture. And then from there I'm going to use pretty much the same technique I've just used. I'm going to declare a variable, dim sh as shape. And then from there I'm going to say set sh equals sheet1 dot shapes dot add picture. Now there are two separate methods for adding pictures. There's the old-fashioned add picture and the new modern inventively titled add picture to. The genuine only difference in these two methods is that the add picture to method has an extra parameter that allows you to specify whether the picture gets compressed or not. So you can choose to compress the image so that it reduces the file size of your Excel workbook. I'm just going to use the add picture to method just to demonstrate that fact. So I'm going to say add picture to, then open up some parentheses, and you'll see that this time the parameter list is somewhat different to the basic add shape method. I've got to specify a file name, I've got to specify whether I'm linking to that file, and I've also got this extra compress parameter right at the end. Also save with document as well. So I've got left, top, and width and height as usual, plus all these extra additional ones. So let's just really quickly go through some of the basic things I need to change. I'm going to separate this code onto multiple different lines just to try to make it easier to read. So I'm going to use a space underscore character, the continuation character, and on the next line what I'm going to do is specify the file name parameter. So file name colon equals. I don't need to use the named parameters. It's much less code to write if I don't name the parameters, in fact, but when you've got so many to fill in, it's usually worthwhile naming them just to make it easier to read. So, the file name. I know that my file is currently sitting on my desktop. It's called wiseowl.jpg, and then all I need to do at this point then in the VB editor is enter a reference to that file path. One quick simple way to get access to my desktop rather than writing out the full file path is to use the environ function. So we can use the environ function, which allows me to refer to the user profile, which is essentially a reference to the root of my user profile path, and then I can concatenate to the end of that a backslash, and then desktop, and then another backslash, and then wiseowl.jpg. Okay, so that's the file name specified. Next, I need to choose whether or not I link to the file. So in this case, what I'm going to do is say false. I don't want to create a link to the file. I would like to embed it in the workbook. So I'm going to set the link to file parameter to be equal to false. Or in fact, MSO false, Microsoft Office false in this case. Then another comma, space underscore, and the next property is I want to say save with document. So in this case I'm going to say save with document equals, or sorry, colon equals MSO true, and then a comma, space underscore, and then the left top width and height properties, or just as we've seen earlier on. So annoyingly I've got to type in left colon equals, let's set this to a left of, let's go for, I don't know, something like 100, and then I'll put these onto the same line actually because they're kind of related. So left top, and I'll set that to a top of, let's say 20, and then a width and a height. Now here's one of the annoying things about inserting images. Ideally I'd like my image to be inserted with the same relative dimensions as it currently has, so I don't want to distort the image when it gets inserted. But unfortunately, at this point, I'm forced to specify a width and a height. I'm going to show you a way around that in just a moment, but for now I'm just going to enter a width of, let's say, 50, and then a height of, let's say, a height of 100. So nearly there. Finally, I've got one more parameter to fill in, so I'll put this onto a separate line. So this time I've got to specify the compress parameter. So compress is unique to the add picture to method. If I was just using add picture, I would not have to do this. But in this case, I've got to say compress, let's say MSO picture compressed true, just to reduce my file size. Not that it's a particularly large image in the first place, but there we go. So having done that, let me just bring back the Excel worksheet so that you can see this, and then if I were to run this subroutine, let's have a quick run, and there we go, there's my image inserted. Now hopefully you can see, even from this basic example, that the image is distorted. It's slightly narrower than it should be, or slightly taller if you prefer to think of it that way. So it's definitely been stretched in one dimension. So to avoid that happening, what we can do instead is kind of cheat a little bit. I'm just going to switch back to module number 2 briefly, and then I'm going to delete all sheet 1 shapes. So I'm going to just select that subroutine and then hit the play button to run it all. Then back into module number 3, I'm going to change the width and the height parameters to have a value of -1, which isn't intuitive by any means, but if you set those parameters to -1, and then if I run the subroutine again, I'll find that the image gets inserted with its original dimensions, which is great. What I might then want to do is change the dimensions of that object. So one quick neat way to do that is to change one of its properties. I'm going to say sh.lock aspect ratio equals MSO true. So that means that if I change it in either dimension, the other one will change to maintain its dimensions and maintain its aspect ratio. So what I could then do is change either the width or the height. Let's go for the width. This time I'm going to say sh.width equals 100. So again, I'm just going to delete this picture manually just for the time being, then head back to the VB editor and then run that subroutine one more time, and you'll see this time it's inserted. I've locked its aspect ratio and increased its size, but it's not stretched. Another type of object we drew on the worksheet manually earlier on was a button, or a form control button, and we can write code to do that too. So let's have a new subroutine just down below this one. We're going to say sub add new button. And then to make that work, we'll take the same sort of approach as we've already taken. Once I've spelled button properly, there we go. So I'm going to say dim sh as shape, and then from there we're going to say set sh. Let me just give myself a little bit more space so you can read this a little more clearly. So I can say set sh equals sheet1 dot shapes dot add form control. So it's just yet another unique method for adding a particular type of object to a worksheet. So in this case, I've got to choose from a list of specific form control objects, just as you'd expect if you were using the insert tool from the developer tab of the ribbon. The option I want in this case is the button control, and then I've got the traditional left top height and width properties to modify as well. So let's say left of, I don't know, it doesn't really matter at this point, let's say left of 50, a top of 100, a width of 200, and a height of 50, for example. So having done that, if I were to hit F5 to execute it, I'll see my new button gets added in. Of course, once you've added a button, it won't have any default action attached to it. So what I'm going to do at this point is just manually, or in fact let's just go back to module number 2 and delete all the sheet 1 shapes by running that one manually. And then what I'm going to do is head back to module number 3, and immediately after I've added this button to the sheet, I'd like to assign an action to it. So I can do that by saying sh.onAction. That's a simple property, and what you can do with this is simply refer to the name of a subroutine that belongs to this project. So in this case I can type in some double quotes, and what I'm going to do is, as soon as I click on this button, I'd like it to delete all the shapes on sheet 1. That will include itself. So I'm going to do that by saying delete sheet 1 shapes. So I've got a nice simple way to tidy up. So having done that, if I were to run the subroutine again, that will create the button. I might just go through and create a couple of these other shapes as well. So let's insert the image and let's insert the heart shape as well. But if I switch back into Excel, if I clicked onto the button, it will delete all the shapes on sheet 1 because I've assigned that action to it. One of the cool things about actions is that they're not limited to form control buttons. You can add an action to any shape, so I could make the heart shape have an action. So if I just in fact just copied that line, let's just copy that particular line and add it into the basic shape routine. So if I run this one, then at this point I've added an action to the heart shape, so clicking on the heart shape will delete itself. Not particularly useful, I admit, but just to demonstrate a point. And then again I can add that one to the picture as well, so I've just copied and pasted the exact same line to the picture, and if I can run that one, I can also then click on the picture to have it delete all the shapes on that sheet. I'm sure you can think of more useful routines to attach to the click event of shapes and buttons, but that was just to demonstrate a simple principle that you can attach an action to any sort of shape on a sheet. Okay, so adding one shape at a time is fairly straightforward, but what if you wanted to add multiple shapes in the same procedure? Let's start with a simple example that adds a basic row of boxes, so just a row of rectangular shapes across the top row of the worksheet. What I'm going to do is create a new subroutine called add multiple shapes, and then in there I'm going to start by declaring a few different variables. So we'll have our standard sh variable to refer to each shape as we add it, just in case we wanted to format it later on, so dim sh as shape. Then I'll want to have some sort of counter variable that keeps track of how many shapes I'm adding, so I'm going to say dim I as integer. What I can do then is declare a couple of variables just to keep track of the positions and dimensions of my shapes. So I'm going to declare a variable called sh_left, and in that variable I'm going to essentially calculate the left hand position of each shape as I add it to the sheet. So sh_left as integer. And then I wanted to have a couple of constants that keep track of the size of my shapes. So I'd like to have this fixed while the procedure is running. So let's say something like dim sh_width. Sorry, beg your pardon, rather than a variable, I'd like to declare a constant. So I'm going to say const sh_width as integer, and then assign a value of, let's say, 50 to that. I can do essentially the same thing to declare a constant for the height. So I can just copy and paste that, and then say const sh_height as integer, and make that equal to 50 as well, so I'll end up with some square shapes. And then what I'd like to do is write a loop that processes a set number of times to add a row of rectangles. I'm going to do that using a for next loop, so I can say for I equals. And in this case, let's say I wanted to have just 5 basic rectangles in the top row, so I can say for I equals 0 to 4, give myself a couple of blank lines, and then say next I. Okay, so the important thing to do for this particular example is to calculate the position of the left of each shape. And what I would like to do to make that work is essentially just multiply the value of the loop by the width of each shape. So the first shape will be multiplying 0 by 50, which would give me a position of 0, which means the first shape will sit at the exact left-hand edge of the sheet. The next time the loop goes around, that will be 1, so the left will be 1 multiplied by 50, give me a position of 50, so that will sit directly next door to the original one, and so on and so on and so on. So I'm simply going to say sh_left equals I multiplied by sh_width. Nothing particularly complicated, sort of high school maths at that point, maybe even primary school maths. Okay, so at that point we can then add in our new shape. So I can say set sh equals sheet1.shapes dot add shape. So we'll just use the generic add shape method, and I'm going to look for an MSO shape rectangle. And then all I've got to do is specify the left, top, width and height parameters. So the left will be sh_left. The top will be, let's just say 0 for the time being. So the top, of course, I want it to sit across the top row of the worksheet. So that will be 0. Then the width will be sh_width, and the height will be sh_height. I can close the parentheses. I could format them if I wanted to, but I just want to check that this one works first of all. So having set up that basic loop, let's just give this one a very quick test by hitting the play button or the run button, and I'll end up with 5 different shapes sitting in line with each other across the top row of the sheet. We can use exactly the same sort of principle to produce multiple rows as well. So let's say we wanted to have, I don't know, let's say 4 rows as well as these 5 columns. We could declare another variable which keeps track of a second loop to loop through the number of rows. So let's say something like dim j as integer, just to be inventive. And I'd also like to calculate the top position of each shape. So let's say dim sh top as integer as well. Having done that, so I'll just change the casing of that. I meant to spell that with a capital S and a capital T and failed on both. Having done that, what we can do is wrap up this current loop. We know that this one works quite well already to produce a single row. So for that single loop, what I'd like to do is wrap that up inside another loop. So I'm going to say for j equals, in this case I'll say from 0 to 3, so that'll give us 4 rows in total. The first thing I'll do inside that loop is calculate the top position, and we can do that in exactly the same way as earlier. We can say sh top equals, this time it'll be j multiplied by sh height. So that gives us the flexibility to modify the height of the shapes and still have everything lining up neatly with each other. I'm just going to indent the current for next loop so that it's at the same level as all the other code inside that outer loop, and then say next j at the end, and finally we can just give this one a quick simple test. Once I've changed the parameter which specifies the top position of each shape. So rather than referring to the value 0 this time, I want to reference the value stored in my variable sh top. Okay, so let me just try to separate this across multiple lines so it might be a little bit easier to read. So having done that, what I can do is just run the entire subroutine and I'll end up with as I say, 4 rows and 5 columns. I'll probably also want to delete, I've actually got 2 top rows now, so then the new set that I've just drawn have been written over the top of the existing ones. Let's just delete all the shapes on sheet 1 again, just to prove that that does work from scratch. And there we go, so there's all 20 shapes. Now the great thing about this is you can modify this in whatever ways you like. So if you wanted sort of slightly less tall shapes, I could go for a sort of half height shapes, so change the height to 25 and then again clear the contents of the of sheet 1 first, and then just run this subroutine again. So I get half height shapes, and then any other modifications you wanted to make, you can change the number of rows and the number of columns just by increasing these values for the loops. Okay, so that's about as far as we're going to go for the basics of working with shapes in this video. What we'll do in the next video in the series is look at some of the more sophisticated options for formatting shapes, so something above and beyond the basic fill formatting we've covered so far. We'll look at things like colour gradients and line formatting and even some of the fancier 3D effects. Hopefully what you've gotten out of this video is the absolute basics of being able to refer to shapes, manipulate their size and position, and also add new shapes to a worksheet of a variety of different types. Hope you found that one useful so far. Thanks for watching, see you next time. If you like what you've seen here, why not head over to the WiseOwl website where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.